Hello and welcome to the Daily Space for today, November 21st, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Our CosmoQuest channel brings you the Daily Space most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. And we're so glad that all of you are here. And today's news, well, it's been a really weird day in space news. And we're going to touch a bit on spacecraft, on sky events, why entomologists shouldn't look at rock fields and all of that before we do a deep dive into gamma ray bursts. So let's start with SpaceX. SpaceX, oh, you poor people. So SpaceX tried a test yesterday. SpaceX has been working on developing its new Starship vehicle at facilities in Cocoa, Florida and Boca Chica, Texas. Conveniently, the Boca Chica facility can be seen through telephoto lenses, and various folks down in South Padre Island have been streaming its construction. In particular, the Lab Padre channel on YouTube has done a great job catching all the excitement of this new spacecraft. And yesterday, things got a little more exciting during cryogenic loading test than anyone probably wanted. While filling the Starship with either liquid oxygen or liquid nitrogen, something went sideways, and the vehicle expelled pieces and gas out both ends. While the outer shell stayed standing, it is now visibly crumpled. In a statement about this incident, SpaceX stated simply, "The purpose of today's test was to pressurize systems to the max, so the outcome was not completely unexpected. There were no injuries, nor is this a serious setback." I have to say, I love SpaceX's willingness to try things and expect that sometimes when you try, instead of doing, you do not. This is the part Yoda was missing. There's always a try. You just don't know if the outcome is going to be do or do not. And this was really a spectacular do not kind of try. Speaking of trying, I'm hoping all of you will go out tonight and try to see tonight's freak meteor storm. During past orbits around the sun, our planet passed through a tight-knit band of debris that was left behind by an unknown comet or active asteroid. During these past passages, amazing storms of meteors, shooting stars that are actually just grains of material hitting our atmosphere, amazing storms were observed to briefly light up our planet's sky. Called the alpha monoceratides, and I'm sure I mispronounced it. This kind of an event last occurred in 1995, and now the orbits of our world and that debris have aligned again. It is predicted that between 11 p.m. Eastern and 1 a.m. Eastern tonight, there should be a storm of meteors that will have a peak rate of 7 meteors a minute sometime around 11:50 p.m. Eastern. There's only a 32% illuminated crescent moon, and you can't expect that moon to be an issue. And in many places, that moon won't even be in the sky. This storm will center on a faint and mostly ignored constellation that I struggle to pronounce, Monocertides. This constellation is located off the shoulder of Orion and above Orion's dogs and the dog star Sirius. Here in the Great Plains, we're looking at solid cloud cover, and satellite images aren't looking good for most parts of North America and Europe. So those of you in the Southern Hemisphere, you may have better luck, and since this is an equatorial storm, it will be visible pretty much wherever it is dark and clear. Hopefully someone somewhere will get some images and let us know if the 1995 storm is repeated. Okay, so there is no easy way to transition to our next story, so I'm just going to be blunt. Ohio University entomologist William S. Rossimer presented a conference poster at the Entomology 2019 conference, claiming he has found evidence of bugs and reptiles on Mars. And he is wrong. By zooming in too far on images of Martian rocks and by tweaking the contrast just so, he was able to find sets of rocks that looked reminiscent of insects, snakes, and lizards. None of these rocks were observed to move because they are rocks, not insects, snakes, or lizards. Mars is a vast rock-strewn wasteland, and it is easy to find rocks that look like anything you want if you look at enough images. Over the years, folks have found rocks that look like Bigfoot, look like human faces, and so much more. And we've done the same thing right here in the CosmoQuest community with rocks on Bennu. Human beings are really good, even here on Earth, of looking at rocks and finding that they look like living things. They are still rocks. Our human mind is programmed by evolution to find patterns, and it is so much better to see snakes that don't exist in patterns in the rocks than to miss the snake you are about to step on. There could be, very well, fossils on Mars. I hope there are, and I hope we find them. This isn't that discovery. And I really feel bad for Dr. Rossmer because he's about to take a lot of grief from a lot of planetary scientists that would like him to please get off our scientific lawn. The thing is, claims like this can do a lot of harm to our ability to communicate science with the public. This can lead to weird conspiracy theories and will make it harder for us to communicate actual discoveries that may happen someday in the future. I'm frustrated by this entire situation because I don't think Rossmer knew ahead of time what a mess he was about to make, especially of his inbox and his mentions. I don't think any of us wanted to spend time this week saying, it's not aliens, it's rocks. It is not aliens. It is rocks. Okay. Moving on to our top science story of the day. This week, at least 7 press releases from 7 institutes went out announcing that gamma ray bursts of record energy had been spotted and studied by more than 300 astronomers. In 3 papers coming out in Nature, these scientists shared the story of long gamma ray bursts, GRB 190114C and GRB 180720B. Gamma ray bursts come in 2 basic flavors, long and short. The short ones, these are associated with the merger of dead stars like neutron stars, while the long ones are believed to be the death of massive stars going supernova and forming black holes. Gamma ray bursts were first discovered in the 1960s by satellites designed to monitor the Earth for nuclear tests. And it wasn't until the late 1990s that astronomers were first able to locate the point of origin of a GRB and match the gamma ray burst with an optical afterglow. This long lag between the discovery in gamma ray light and the discovery in optical light comes from the difficulty of focusing gamma rays and identifying where they come from with any significant accuracy. The challenge was made all the greater by the extremely short period of time that these objects are generally optically bright. In the 2000s, the Swift telescope made discovery easier by combining in one spacecraft instruments to observe in gamma rays, X-rays, and ultraviolet light. The Fermi telescope further improved the situation with its launch a few years later. Since Swift's launch, burst alerts have been distributed through an automated system to observers all around the world, allowing anyone with a telescope to provide follow-up observations to gamma ray bursts. And this network has made observations of optical afterglow identifications. Okay, thank you whoever just donated something. You made me screw up my sentence, but that's okay. I am so grateful for whatever you just did. I need to open a different page to find out what you just did. So I'm going to pause and I'm going to acknowledge what you did. Thank you, Wayne Johnson, whose birthday it is today. Okay, so back to the science. Since the launch of Swift, Burst alerts have been distributed through an automated system to observers around the world, allowing anyone with a telescope to provide follow-up observations to gamma ray bursts. And this network has made observations of optical afterglows and their identification of GRB locations a regular occurrence. Seeing them regularly, however, doesn't mean they are well understood or that they don't have surprises still in store for us. On July 20th, 2018, both Fermi and Swift issued an alert about a new powerful GRB that had a maximum photon energy of 5 giga electron volts and gave off a total energy of roughly 5 times 10 to the 46 joules of energy. This is comparable to what our sun will give off in its entire life. The optical afterglow of this object was visible for a remarkable 30 days, and this GRB is among the 10 most powerful no matter how you try to characterize it. Study of this object allowed the processes driving the kinds of light that we see to be constrained, and a paper led by Hassan Habdallah indicated that these energies may derive from some sort of a synchrotron process where magnetic fields drive electrons to accelerate to tremendous energies that in turn release powerful photons. Synchrotron processes may not be enough to explain the highest energies, however, and it may be that some sort of inverse Compton scattering may allow electrons to transfer even more energy to photons. Whatever is happening, this particular GRB demonstrated that these processes can last for hours on end. We don't really know just how powerful a GRB can be and what factors constrain it. In 2 additional papers in the same issue of Nature, astronomers focus on a January 14th, 2019 GRB that had a similar total energy to the 2018 event and had a maximum energy in its photons that topped 1 tera electron volt. This is an energy that had previously only been seen in the Large Hadron Collider. This is 1 trillion times as much energy as we see in visible light photons. European astronomers were able to get time on the Hubble Space Telescope to study the environment of the GRB and found that it occurred in the dense region right in the middle of a galaxy 5 billion light years away. According to one of the lead authors, Andrew Levin, this is really unusual and suggests that might be why it produced this exceptionally powerful light. Put another way, if a giant star goes supernova in a dense environment, it may drive the event to be higher energy than would occur in isolation. These discoveries give new inputs for theorists to work with as they try and model how massive stars explode and how their energy interacts with their surroundings. This also highlights the importance of having telescopes programmed to automatically respond to burst alerts. The MAGIC array, yes, MAGIC, it's an acronym, array was able to get on target less than a minute after the GRB was discovered, and it rapidly slew its 64-ton masses to point at just the right point on the sky to measure the gamma ray photon energies. As technology improves and as more GRBs explode near, but hopefully not too near our galaxy, we can only improve our understanding of these most energetic events in our universe. And that's all our science for today. I will now take your questions. And while you type them in, I'm going to remind you, use that purple circle with a purple star in the center to make it easy for me to find your questions. And while you type them in, I'm going to let you know this show is produced by the fabulous Susie Murph, who does all the behind the scenes stuff and sometimes even appears here on camera when Andy and I aren't around. We are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. And we are made possible by you. Yes, you. And thanks to you, I don't have a fundraising box beside me. See? No fundraising box. This is because you guys funded us. We're here. We're happy. And I'm not begging for donations, although I will stick up. I'm not quite sure why it's not there. Somewhere. Let me switch to screen transition. Oh, I'm on the wrong screen. Awkward. Awkward is occurring. Chat. Transition. There we go. Although I will say, if you follow us on Patreon, we can get you more. We can send you the transcripts, announcements, let you know what's going on behind the scenes. So, thank you. And thank you, Broken Symmetry. Oh, Eddie did not come down with me today. He is happily upstairs next to a radiator and he was dead asleep. And I didn't have it in me to bring him down. He'll be here tomorrow. I promise he'll be here tomorrow. I will wake him up. Sometimes you just have to let sleeping dogs lie. Anyways, thank you. You're an awesome human. Okay, so we are a production of the Planetary Science Institute. I'm grateful for everything you do. Support us on Patreon. We can do more. Okay, time for questions. Scrolling. So right in front of me, Bad Panda Bear asks, it scrolled off my screen. Are these gamma ray bursts tightly focused like beams out of an AGN? Yes. We think that they're associated with the poles of rotation of a massive star such that when the star explodes, we get a jet of gamma rays and you are able to see a gamma ray burst only if you're in the correct place. So yes, they are similar to the jets that we see from AGNs. The process is much faster. It's temporary. There's no accretion disk, but the physics that focus the jets and cause the synchrotron radiation are the same in both cases. Scrolling. I'm just going to scroll up to the top. Okay, scrolling downwards. I did have fish at the beginning of the episode, or actually mostly just an algae-filled tank that has 2 lone fish in it. I'm considering getting additional fish for that tank. Hello, everyone. Scrolling. Looking for questions. There we go. Oh, no, Nightbot is saying how to enter your questions. Hello, Astro B London. Yeah, Larry put it right. SpaceX go boom. They will go boom. But they did it in such a spectacular fashion. Let me pull that slide back up again so that we can all watch the video once more. The the thing about this explosion that gets me is it's been likened to a chimney that you might use to light a barbecue. And I have to agree, that's all I see as well. So there you see your tube of a starship. You can hear the wind. I can hear the wind. You can't hear the wind. And there it goes. Boom. Starship went boom. And the way the gas comes out the top and the bottom just really reminds me of lighting one of those chimneys with too much lighter fluid and it just goes boom with fire. Okay. Per Adam Savage, Bad Panda Bear points out, failure is always an option. It really is. It really, really is. Yeah, Trekker Kev, 100% cloud seems to be the norm. If you zoom out and look at a satellite image of all of North America, it's like Florida is the only part not covered in cloud. Thank you, Trekker Kev, for the bits. You are an awesome human. Thank you. Looking for questions. Yeah, even Bad Panda Bear. So, like, all across America, it's gross. It's never aliens. You're right, DPI 209. It is never aliens. Yeah, Susie has it right. Pareidolia, the problem of seeing patterns where there are none. So Guido, this guy, he's actually like a well-regarded entomologist. He did this in all earnestness. He's just so wrong. Just wrong. Yeah, I feel so bad for him. Yeah, the gem doctor is right. Your local rock shop has rocks that look like insects and such. It's true. It's true. Oh. I like Broken Symmetry's comment. Even my pet rock rolled its eyes at this Mars story. Twitter has not been kind, Paranor. It really hasn't. Okay, looking for more questions, scrolling more rapidly. Happy birthday, Wayne! Happy birthday! Um, I'm going to kill the sound on this. There, now I don't have to listen to it. Um, so Larry asks, is this maybe a starburst galaxy event? They didn't say in the paper that this was a starburst galaxy, and in general, just starburst only means that you have a vast amount of massive star formation going on. Um, Vast amount of star formation or massive amount of star formation. I'm not speaking about the sizes of the stars. The distribution of the size of the stars that form is a function of how much gas is available, how they're getting compressed, and there's in general an initial mass function that gives you that ratio that gets lots of red dwarf stars, fewer middle-sized stars, and a really few number of these massive stars. Now the massive stars are the first to die. So if you do have a burst of star formation, you are going to get gamma ray bursts associated with it, but you don't have to have a starburst galaxy. We have lots of star formation going on in our own galaxy. And when we look at the Large and Small Magellanic Cloud, well, as we talked about in a story last week, their interaction 200 million years ago led to the formation of massive stars. And so at some point, those are going to go boom too. And hopefully, none of them will have the rotational axes pointed at us, causing gamma ray bursts. We're far enough away, it wouldn't be a problem. And as near as we can tell, there aren't any massive stars close enough to us and pointed at us that this can be an issue. Looking for more questions. It's good to hear you guys commenting that Susie did a really good job with Daily Space last week. That is just pleasing. I mean, she's a podcasting pro. She's been around since the early days of podcasting. Um, it's just awesome. We're very pleased to have her as part of our collective. Thank you again, Broken Symmetry. I'm sorry Eddie's not down here. No Eddie today. Let's transition back to having the chat up on screen. Chat transition. There we go. He's dreaming. Yes, Eddie is off dreaming. So, Hammer to Fall asks, how much of an astronomer's work involves complex modeling? How long does it take to learn? It really depends on what type of an astronomer you are. As an observational astronomer, I was the kind of person who always was writing software to reduce my data, to operate the telescope. And then I was processing that data, making measurements, and there was no modeling involved in what I did. Now, other astronomers, that's all they do is they model. And it just really depends on what you do. And there's the entire range in between of what people do. So the nice thing about astronomy is, while you need to know a little bit of everything, you can pick what you specialize in. And so there are people who specialize in the maths, the modeling, the theory. There are other people who specialize in the optics, the engineering of the telescopes. There are people who specialize in using the telescopes. Nowadays, my specialty is writing software that basically takes those images and makes it easier to process them to get data out. And yeah, there's lots of different options. Looking for more questions. I love all the comments on how bits of Starship were hitting new altitude records as they exploded upwards into the air. So Paranor says regarding Mars bugs, I say the pareidolia was second to their wishful thinking. Yeah, the wishful thinking was powerful. So Michael asks, I've looked at my weather forecast, or says, I've looked at my weather forecasts, and it looks as though there may be some clear sky around 5 a.m. to 6 a.m. here, so I might be able to get pictures. That would be amazing, Michael. And Michael has really good camera equipment, and yeah, so there's hope that we'll get stuff. If you get some really cool images, don't be afraid to send them along, because we will not be afraid to use them. And give you full credit. Just to be clear, we give people full credit. Yes, Susie has done a bunch of recording of Daily Spaces for us, where Annie did the live episode and then Susie recorded the podcast. If you haven't already, you should check out the podcasts and consider inflicting them on your friends who are podcast listeners and can't watch videos during the day or just would rather listen to a podcast. I'm really proud of our podcasts. They started off kind of wonky, but we're getting there. I wish we had more time to do better editing, but that will come. Scrolling. Okay. And Susie does indeed have a dog. She just doesn't have a dog cam. We'll work on that. All right, so that rounds out our episode. I still need to go finish editing the podcast for today. And thank you all for being here. And once again, thank you so much for everything that you do to support us. We would not be here without you. And I'm just so grateful that you're making our lives easier by actually supporting us doing this. And we're going to do everything we can to bring you the most science. Susie, Annie, and I will be going to Florida, where the launch we were planning to see has had its date moved. So wish with us that CRS 19 gets delayed just a few days. Just a few days. That's all we need so that we can watch it. And that's all I've got. So once again, my name is Dr. Pamela Gay, and this has been The Daily Space. We come to you most Mondays through Friday at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. We are produced by Susie Murph, and we are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are so grateful that all of you are here to support us. And we are about to raid Oh Bother. So don't go away. Give Oh Bother a fabulous emote-filled welcome as we raid his channel. Wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you on the other side. Bye-bye.